Well, as Alex introduced me, my name is Maximiliano Contieri. I'm from Argentina. I'm graduated and teacher on computer science on Universidad de Buenos Aires. I've been teaching and working, as Alex said, in the industry for about 25 years. I'm practicing TDD for at least 15 years. In this talk, I'm going to show you how to practice with TDD on legacy and coupled systems. We're also going to tear down some common myths of the software industry and TDD. This talk is aimed to people with few experience on TDD. I will start with a very brief definition in case you missed all the talks before mine. Okay, this will be our agenda for the next 20 minutes. We're going to explain TDD in just a few words, show a real impact on a real system. There are out there a lot of TDD courses and katas, as one of the presenters showed out there, but many of them show isolated and simple examples and do not teach us how to insert the whole process and continuous integration, continuous deployment on a real legacy system. We will also show all the software roles sharing the process working together. So this is the definition. I'm going to show the definition just in case you don't know what TDD is about. TDD is a development methodology. I'm tired of saying it's not a testing methodology. It's used for programming, not for testing. The tests are written first, and the solution always have to be super simple, even if it's hard-coded. You know that. We must never anticipate under any circumstances to potential solution. This allows us to avoid very complex and imaginative solutions that do not have contact with client real requirements. And it gives us full coverage on all the cases described. You know that this technique was created by Ken Beck in 2003, and today it's used in many parts of the world, as you may be aware. The cycle, I'm going to tell you this again. I assume you are familiar with XUnit family for running automated tests. First, you add a test solved basically on behavior, important behavior, as Mario said, different implementation decisions such as data structures, algorithms, and so on. Second, you run all the tests. The test created in the previous step should fail, the former not. Third step, you write the simplest solution, always the simplest solution. Do not program more than necessary. Following, keep it simple, keys, and YAGNI, you're not going to need C principles. And optionally, and this is important, optionally, you might refactor the code when it starts to think, as it has had a lot of code smells. Never, never do steps 1 and 4 at the same time. Never. This is known as TDD cycle. And the design benefits were shown all the day today, but I'm going to tell you a bit. With TDD, we will get more decoupled system. Coupling is very visible. This is more evident in large and fragile systems and not so much in small exercise or katas. The code is more modular and easier to debug in isolation. We have more coverage. The steps are very small. We listen a lot about baby steps today, very baby steps, and we avoid making premature optimizations ahead of time. This methodology is based on how we learn from childhood, based on examples and not on definitions. We learn when we were told by examples. In this talk, I'm going to destroy a lot of myths. Let's start destroying some of them. TDD does not guarantee good designs. Good designers are the ones that guarantee good designs. So if any one of you is selling TDD, do not sell that the designs are good. Good designers make good designs. Okay, so let's see which are TDD's preconditions or requirements. We need to be in full environmental control. We cannot allow global variables, no global functions, no singletons, no configs, no database, no cache, no external OP calls, no side effects, anything external which is not under our control. TDD will help us detect the coupling sources, and lead us to a cleaner code and focus on solving essential problems, business logic, and encapsulating accidental and implementation problems out there of the code. So another myth, we cannot do TDD on couples. I'm tired of listening from my students this. I have a couple system. This is a myth. This is what this talk is about, and we will try to demolish this and other myths as well today. Okay, let's see an example. Enough talk. Well, this is a real example from a COVID-19 streaming ticket reservation system for online concerts. The user chooses hierarchies with regular expressions using our user interface. And regular expressions have very poor performance in some relational databases. We need to avoid them as much as possible, given our current database stack. We cannot change, unfortunately, the database stack. This is another myth. We're going to crash the myth that TDD cannot be used to improve the performance of a system. And this is not contradicting some talk before that said TDD should not be used for performance testing. Of course, it should not be used, but it can tackle some performance issues. Okay, this is the example. Our system generates these types of dynamic queries based on user inputs. If you don't know SQL, think of regular expression. Maybe you're familiar with SQL. There are just 5 text pieces. We have 5 different conditions. You can see them on the OR clauses. Patterns in red are redundant and yield unnecessary and costly operation on the database. They do not add value. For example, the second is represented by the third and the fifth by the fourth. Arranging is not very smart to infer or deduce that rules. So we should transform the previous slide into this. This example is more performant and semantically equal than the previous one. This is the whole problem we need to solve. Seems a piece of cake. Well, let's start with TDD. This example is in PHP, but I want you to look at it as if you were pseudocode. I don't care if you know or not TDD. I'm not going to enter into language details. TDD starts the cycle by asking us to create a case. Your first thing you need to do is to create a case. Neither the class nor the function that solves the problem are defined, just the test case. I'm defining a fancy like pattern simplifying class and a simplify method that don't exist yet. They are probably very lousy names. First names are always lousy, no problem. We always have step 4 and good IDs to make refactor. That's what we should use, good IDs and not text editors. We will always start with the simplest case. In this case, I'm using a methodology called zombies. You might have heard of it a couple of hours before. I think Joe showed you zombies. Zombies guides the order of the cases so that we do not forget any of them. This case is the empty one. The 0 is the Z in zombies, asserting that if there is nothing to simplify, nothing is simplified, the 0. Step 2 of the cycle, we need to write the code. The simplest solution, always return an empty array no matter the input. The parameters you pass to the function do not matter. Solution is hard-coded, return an empty array. That's the 2 brackets after the return, in case you don't know how arrays are built in PHP. Always return hard-coded. And this is a myth. Hard-coded is not a bad practice. We need to remove this from our heads. Unless we have the crystal ball and know the algorithms for everything, but that would not be doing TDD, but futurology. If you want to make futurology, you can write the algorithms without the tests. Let's feed with more examples. We are on the cycle. This is the loop 2. Step 1, we add another simple test. If there is only one term, the simplification is the same term. Of course, the test does not pass. So in step 2, we modify the implementation. The solution has to work for all pre-existing examples. It was just one. And here we see the test and the solution. We continue to return hard-coded, sending out the input parameter instead of the empty array. With this solution, we cover the first 2 cases, the previous and this one. Okay, but we need to complicate cases gradually. We test 2 independent expressions. To our surprise, the pre-existing code already works. What is it telling us about our solution? We return what we received. This works for 1 or n independent elements. We got ahead of ourselves with the solution. Maybe we will delete this redundant, because it's redundant, test later. For now on, we leave it happy that everything works. Okay, but let's start with the funny cases. One expression that does contain the other. Luckily, the tests do not pass. TDD asks us to fake it till we make it. Okay, we already fake it a lot. Now we need to make it. So, luckily, these tests do not work, of course. So after we skip some TDD steps for short for this talk by hard-coding some elements, but this is a possible solution we came across for related patterns using the substrate compare function and a filter. Substrate compare is a function in PHP that searches for prefixes. You can use similar functions in your language. This solution makes all the previous tests pass, of course, 2 nested loops, insert for redundant patterns. When iterating, we see it is included and we remove it. It's not clean code, it doesn't matter. We don't have confidence enough to refactor yet. We are learning from the domain. However, this solution is ugly, not very declarative, not very performant, and too complex. Okay, let's demolish 2 other myths. We shouldn't write algorithms without test cases. The algorithm that emerged was based on several test cases. The current code can be ugly, can be highly imperative, can be non-declarative. We will improve it once we have confidence with our IDE tools. So code must not be clean all the time. Well, some bees tell us to look for the capitalization axis because most relational databases engines ignore capitalization in searches. We write an explicit test that ensures this property. This probably won't work if the user changes the case from uppercase to lowercase. And this is something we have to make sure. So we write the test. Of course, it didn't work, but we need to fix it. We tell the substrate compare function that the comparison has to be case insensitive. This is the true parameter you see at the end of line 4. We could have guessed from the outset, but we are following a coverage map, and everything is documented on the test. Our flow is documented on the number of the tests. Tests are living documentation. The algorithms are documented with tests. They are not documented with comments. Test numbering shows our learning processes. Okay, now we have step 4, please. It screams for a refactor for readability. The simplified function was horrible. We are confident enough to refactor now because we have a battery of automated tests. I'm going to refactor without changing the test. You cannot change test and refactor at the same time. One extract method, refactor, and everything is a bit more declarative. Use IDAs, don't use text editors. All tests keep passing. The refactor, of course, worked because it was an automated refactor. So we test the real scenario, and we are happy it worked. We can simplify what we needed. We are done, and this is the end of the TDD exercise. We just now need to inject the solution into the real system. We need to simplify the collection of texts that are used in the second line. So far, we get them directly. Now we have to simplify them. So we put our code between line 1 and line 2. This is the injected code. We inject the processing and simplification of terms in our system, and we are done with the code. Commit, push, but what happened? The QAs tell us that the pattern to look for could be in the middle of a word, and that was not analyzed. QAs perform the black box testing process and complement TDD job. They are not disposable. So there's another myth that software development is an individual activity and it's just done by the programmers, but QAs are sharing TDD processes by contributing with use cases. We are learning from the domain as we code, so requirements, as you might know, are not frozen, and we are learning. The requirements are not frozen, or we don't know them in depth yet. We have to discover them. The QAs bring us 3 cases that look for patterns in the middle and not just at the beginning of terms. That was their request. This test data is suggested directly by the QAs and therefore not from the music streaming domain, but and of course they are in Spanish because QAs speak Spanish. We validate the proposal with the end user to see if it complies with the business rules. Likely they do, so we write the test and fix the code because it was not working. The code we started using, we changed the auxiliary function that used it to a strike pose, which is case sensitive and also searches within a string. The previous functions just searched only at the beginning. We are within our simplifier. We're not changing the injection point. The code from outside does not change. The change goes to production and goes live with the plug changes. Customers are happy. End of the talk. No, well, shit happens. We find errors in production with sentences generated like this. The statement with an empty where clause is not valid for SQL engines, and the optimizer messed up, screwed up, and we didn't see it coming. So we must correct it. The QAs help us see the test case. They also contribute to the TDD process. We were removing the 2 terms if they were the same with different case. The end user just came up just with that case. We had to leave one representing both. We cannot remove both. There's another myth. It's not just programmers who participate in TDD. The QAs continue to contribute actively, and the production technical support team also does TDD with us. We do some pre-processing before we start simplifying, and everything works. We do it in a private method that is called remove duplicates, that does this, removes duplicates, that should only be used by the simplifying internally. That's why it is private if your language supports privacy. And there's a myth that whenever we add a private method, the same question arises. And this question was today on the chat. Should we test it or not? The answer is right there. You can go to the site and find the answer. You input your private method and it tells us if you need to test it or not. So solution goes back to QA. We are on the cycle. We are on the development cycle. But QAs find new bugs. The assertion expects an uppercase, but our preprocessor normalizes it to lowercase. There are two ways to fix it. First, we take the error as acceptable in the problem domain. It is acceptable. Second, carry out a solution, a magic solution, making the problem very complex. We don't guess. We don't imagine answers. We involve the customer or the product owner who accepts the first one. The client also participates in TDD and help us define the cases. So we push the code, but the code reviewers provide improvements validated by the end user. They say, hey, wait a minute, something that does not have the word head also does not have the word Radiohead. Could we use this immersion property? We check again with the product owner and she agrees. Code reviewers also contribute to TDD. Everyone is contributing in TDD. So the simplifier isn't change it because we just have to change the function call and model both the positive and negative cases. But we don't need to add tests since the simplifier is not changed. Well, it worked out. Happily, it worked out. We were able to do TDD on an existing system. It was a collective and iterative process. Everyone contributed with cases. We can keep adding new cases without breaking previous ones. We have a battery of tests. The solution were simple, covering the use cases. And in the meantime, we tore down some various preconceptions of the industry and software engineering. So what do we have as a future work? Well, I didn't mention, but we need test doubles to comply with the complete control of the full and main time. We need to be radical on that. We need full control, and that's what test doubles are for. And as a task, you need to start using TDD tomorrow. I hope that after this conference, you will be using it if you were not already. And personally, I advise you to tell everyone to avoid the Hello World tutorials, which are very bad. Hello World is coupled to the console, and change them to assert false. Start your first programming line on college should be this assert false. And I challenge you to dare your students to do so. Thank you very much. You can follow me on Twitter. You can see me there in my blog. As Alex said, I write a lot about TDD, software designs, and code smells. And I'm very happy you stayed with me until now. It's very late here.